Good day, ma'am. Good day, everyone. I am Maria Erica Emanuel, and I will be discussing biomagnification. Biomagnification refers to the process by which toxic chemicals build up within predators. This usually occurs across an entire food chain and affects all of the organisms. However, animals higher up in the chain are more impacted because when predatory animals consume their prey, they also consume all of the toxic chemicals within the said prey. When these toxins aren't easily excreted, they build up in the animal system through the process of bioaccumulation. Therefore, as the food chain progresses, toxin concentrations also increases or magnifies. For example, at the bottom of the food chain, plankton are infected with mercury and eaten by some small fish. Each small fish consumes 10 times their weight in plankton over a period of time. The fish will now have 10 ppm of mercury in their system. Now, these small fish are eaten by a school of larger fish who consume 10 times their weight each. The larger fish will now have 100 ppm of mercury in their system. This process continues all the way up the food chain to animals like eagles or even humans, where concentrations of the toxin reach their highest and the health dangers are the greatest.
My name is Christian Ree Imongawe, and my topic for today is bioaccumulation. Bioaccumulation is a gradual accumulation of substances, such as pesticides or chemicals in an organism. Bioaccumulation occurs when an organism absorbs a substances at a rate faster than that, at which a substance is lost or eliminated by catabolism and excretion. Example of bioaccumulation is mercury building up in fish, pesticide building up in small animals. Bioaccumulation is important for several reasons. Bioaccumulation may inhale the persistence of industrial chemicals as a whole, since they can fix the tissue of organism. Bioaccumulation also can store chemicals that can directly affect an individual's health. That's all.
Measuring toxicity. So, what is toxicity? So, it is a substance which becomes toxic at the dose which begins to damage an organism. Let's say, for example, all substances have a certain toxicity. For example, sulfur. Even though there are lots of variations in its effect to different kinds of species, but let's have for instance to humans. Large doses of exposure to sulfur can be fatal to humans. Why? Because if you inhale a large amount of sulfur, it can quickly dissolve with moisture in the lining of our lungs and noses and burn our mucous membrane. Therefore, it can lead to breathing problems and other respiratory illnesses. So, acute effects. It is a certain chemicals or substances can be toxic, even a minor or a one-time exposure to that certain kind of toxic, and this is known as acute exposure. So for example, a venom of a snake, even it is a single or small amount of venom from a snake, it can incapacitate their prey because it is a poisonous or toxic substance which is secreted by the animals. So that is just a acute effects of toxic. Now we have chronic effects. So chronic toxicity, it is the opposite of the acute toxicity because it is a measure of how a toxic substance is over a longer period of time. So this could be anything from weeks to years. However, some toxins work by damaging the body through a series of small exposures and can lead to a chronic exposure. So let's have, for example, a tobacco or a cigarette. So a single cigarette is unlikely to have a toxic effect on someone, but smoking numerous times or numerous numerous cigarettes over the course of an entire lifetime will result into a development of longer period into toxicity. This can lead to lung cancer and other respiratory diseases.
At this point, I will be presenting the steps in the risk assessment process, and I will be assigned to discuss the first step, which is the hazard identification, and the second step, which is dose response assessment. So these are the four steps in the risk assessment process. First is the hazard identification. Second is dose response assessment. Next is exposure assessment. And lastly, the risk characterization. Let's start with the first step, which is hazard identification. This step aims to identify what might harm you or what might harm the people. This includes the evaluation of the potential risk or danger and the evaluation also of the materials or resources that is being used. The next step is dose response assessment. This step is to identify what are the health problems at a different exposures. And this involves identifying the relationships between the dose of a chemical and the health effects on people.
And for the third step, the exposure assessment. In this step, we will know on how much of the pollutant do people inhale during a specific period, on how many people are exposed. Exposure assessment is the process of measuring or estimating the magnitude, frequency, and duration of human exposure to an agent in the environment or estimating future exposures for an agent that has not yet been released. Moreover, an exposure assessment includes some discussion of the size, nature, and types of human populations exposed to the agent, as well as discussion of the uncertainties in the above information. And for the last step, the risk characterization, we will know on what are the extra risks of health problems in the exposed population. This characterization conveys the risk assessor's judgment as to the nature and presence or absence of risk, along with information about how the risk was assessed, where assumptions and uncertainties still exist, and where policy choices will need to be made. Moreover, risk characterization takes place in both human health risk assessments and ecological risk assessments.